diagram. So moving on to part 3, we need to pretend that we are designing a state machine that outputs 1 if an odd number of 1s were inputted in the last 3 bits of the input. And we're going to assume that we've had a long string of zeros. So basically, we're looking at three inputs, and only 3 inputs at all times. And so really, all this the circuit is a window on the input, and we're basically going to XOR the window. And so when we have so for the Mealy machine, basically, it's going to look like this, where we have X going to D, Q, Q bar, going into here, D, Q, Q bar, and we're going to XOR all of these together to create Z. Our Moore machine, so this is for the Mealy machine here, we've got as a function of our current state and our input. Now if we're going to do the Moore machine, we actually have to make this just a function of the state. So basically we're just going to add an extra flip-flop. So X, D, Q, Q bar, D, Q, Q bar, and now D, Q, Q bar. And we're going to do exactly the same thing here, except we're just going to take the flip-flop outputs, XOR these together, and we have our output Z. So this is our Moore implementation, this is our Mealy implementation, and our state is basically the window on the input. So here, Q1, Q0 is a window on the input. Q2 is unused. Here we've got Q2, Q1, Q0 is also a window on the input, but X is unused for determining Z. So here, since following the instructions, if we're not using a state variable, we can just make it 0 for the duration. So let's do that right away. And now, basically, I'm going to assume that we have the assumption that we've had a long string of zeros. So my window on the input is going to have 0 and 0. And I'm going to label this as Q1, this is Q0, this is Q2, Q1, Q0. So that way I can just basically, I'm just shifting these things down. And so X is going to, the output at the clock edge, X is going to be taken into Q1. And then at this clock edge, I'm going to go to 0, at this clock edge, clock edge, clock edge, so it's 0 here, and then we go across to here, this is Q1, 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 Q1. And now we have Q0, which is basically going to be whatever coming into this clock edge is what it's going to be. So this is going to be, basically it's just going to be delayed by 1. And now Z is just going to be the XOR of X, Q1, Q0. So here we got 0, 0, 0, up until about 3 dots to the end, and it's going to go up here. So now 0, 0, 1, and now we've got here we've got 1, 1, 0, so that's an even number. 0, 1, 0 is an odd number, so it's going to go back up. And here we've got 0, 0, 1, so we're going to stay odd. Now we have 1, 0, 1, so that's going to go to 0. And now we've got 1, 1, 0, so that's even, so it's going to stay 0. 0, 1, 0 is odd, so we're going to go back up. And then we're going to go back to even. So we've got 1, 1, 0, so this is still even. And then we've got here, we've got 1, 1, 1, so that's odd, that's good. And then we've got 1, 1, 1 still, so that's still odd. Now we have 0, 1, 1, which is even, so this is going to drop back down. Now we've got 0, 0, 1, so that's odd, it's going to pop up. And then we've got 1, 0, 1, so that's odd, so it's going to drop back down. 1, 1, 0 is even, so this will stay 0. Throughout this whole thing. Then we've got 1, 1, 1, so that's odd. 1, 1, 1 for a little bit longer. And then we've got 0, 1, 1, so that's going to go out here. Now we're going to do exactly the same thing. So we're going to see Q1 is going to be the same thing as Q2, Q0 is going to be the same thing as Q1, and then we're just going to shift this over. So we've got this. And then Q1 is just going to be the shifted version. And Q0 is going to be shifted one more time. And now we just see, is this even, odd, even or odd? So here it's even. Here we've got odd. Here we've got odd. Here we've got even. Here we've got even. And here we've got odd number. So we've got all three. Now we've got an odd again. Or even, sorry, here, and then we've got 1, 0, 1, so that stays odd. And then we've got 1, 1, 0, so that's still, is that right? 1, 0, 1, 1, 1, 0, so this is still, and then this is odd. So hopefully I did this right. So we've got an output sequence of 1, 1, that shouldn't happen. I made a mistake here, I think. 1, 0, 0. 0, 1. Oh, no, that's fine. Yeah, that's fine. Okay, so here we've got 1, 1, 0, 0, 1, 0, 0, 0, 1. And here we've got 0, 1, 1, 0, 0, 1, 0, 0, 0. And this matches the expectations we have of more being delayed by 1 clock cycle.